section 1.3 from the textbook, which is Gauss Jordan elimination. So we're going to be starting with the system of equations, and the first thing that we want to do is convert it to an augmented matrix. So the resulting matrix will be 1, -1, 0, -2, 2 in the first row, 1, 1, 3, 1, 1 in the second row, and 0, -1, 1, -1, and 0 in the third row. So now we want to put this matrix into row echelon form, so we're going to take this diagonal and convert all of these under the diagonal to zeros first. So the first thing that we want to do is we're going to target this number right here, and so we're going to multiply the first row, and we're going to add the second row. So the resulting matrix will be 1, -1, 0, -2, 2, 0, 2, 3, 3, -1, and 0, -1, 1, -1, 0. Notice how the first row didn't change and the third row didn't change. The only row that we're actually altering with the row operations is this second row. So now we already have a 0 right here, so we already have that covered, but we want to target this number now. So what we're going to do is simply multiply the second row by its scalar 1/2 to turn this number into a 1, and then we're going to add row 3. So we're going to go 1/2 row 2 plus row 3. And put it right here. The resulting matrix is going to be, the first row will be the same, 1, -1, 0, -2, 2. Second row stays the same, 0, 2, 3, 3, -1. And the third row is now 0, 0, just like we wanted, 5/2, 1/2, and -1/2. Okay. So now that we have all the zeros under the diagonal, we want to make all of its leading coefficients 1s. So since I don't have room right here, I'm going to write the arrow right here to represent the row protections, and we're going to multiply row 2 by 1/2. And then we're also going to do row 3 at the same time, just to save space, and we're going to multiply it by its reciprocal, which is 2/5 row 3. And so the new matrix will be, the first row stays the same. We already have that as a 1, 0, 2, -2, and 2. Then we're going to have 0, 1, 3/2, 3/2, and -1/2, and then 0, 0, 1, 1/5, and -1/5. So here is the new matrix. So now that we have this into row echelon form, we're going to start doing the elimination, and we're going to eliminate upwards. So we're going to start with this number to eliminate this number. So what we need to do with that is we're going to multiply row 3 by -3/2, because -3/2 plus 3/2 is 0. So we're going to go -3/2 row 3 plus row 2. And so that new matrix is going to be this. First row stays the same. We're not doing anything to the first row. The only thing being altered at the moment is the second row. So we're going to have 0, 1, 0, 6/5, and -1/5 in the second row. See how we eliminated that number right there. And the third row stays the same. We're going to have 0, 0, 1, 1/5, and -1/5. Now we're going to use the second row right here to eliminate the first row. And in this case, we don't actually have to perform any fancy scalars. We're simply just going to add row 2 plus row 1. And that results in 1, 0, 0, -4/5 and 9/5. And then the second row stays the exact same. So 0, 1, 0, 6/5, and -1/5. And then the third row also stays the same. Okay, now we know that we originally started off with 3 equations in our set of equations, but we happen to have 4 variables. So that hints that maybe we're going to have to do some parameterization. So in this case, we're going to flip to a new page, and I will rewrite the existing matrix so it's a little easier for us to understand it. So the current matrix we have is this. And then 0, 1, 6, plus -1/5. Okay. So this is the matrix, same thing as the last page, just a new page. We need to see what our leading variables are and what our free variables are. And so to visualize this, I'm just going to rewrite this as a set of equations out, and I'm going to convert it out of the augmented matrix. So we're going to have x minus 4/5 w equals 9/5, and we have y plus 6/5 w equals negative 1/5, and z plus 1/5 w equals negative 1/5. Okay, so now we see we have 3 equations with a leading variable of x in one, a leading variable of y, and a leading variable of z. But the only variable that does not exist as a leading variable in an equation is w. So this tells us that w is our free variable. This means that we're going to now rewrite these equations in terms of w. So we're going to solve the leading variables in terms of w. So now I'm going to have x, and using basic algebra, I'm going to say x equals 9/5. We add that 4/5 to the other side, plus 4/5 w, and we're going to say y equals negative 1/5 minus 6/5 w. And I recommend to keep all of like keep them in line with each other. And then z equals negative 1/5 minus 1/5 w. Okay, so now that we have our leading variables written in terms of w, this helps us write our general solution set. So the general solution is the particular solution plus the homogeneous solution, in which the particular solution is the constants, and our homogeneous solution is our free variable w. So we can say that our solution x, y, z, and w, and also w in its own equation is w equals w, because that's what we're parameterizing with. So our solution for x, y, z, and w equals our particular, which is just our constant. So we're going to have 9/5, negative 1/5, negative 1/5, and we do not have a constant in this equation for w, so we're just going to put 0, plus our homogeneous solution, which is the coefficients of w. So we're going to have 4/5, negative 6/5, negative 1/5, and just 1. And this is w. And w can be all real numbers. And so this is our general solution set. And that's it. Thanks for watching.